Welcome back to the classroom. Today's topic is the study of MX25L1005 integrated circuit. This video is sponsored by BuyMote shopping app. BuyMote e-shopping application is one of the online shopping app. The MX25L1005 block diagram shown in screen, which was manufactured by Macronix. The device is a CMOS serial flash memory chip with a capacity of 148,576 bits. It is designed to work with a 3-wire bus using a serial peripheral interface and software protocol. Internally, it is organized as 131,072 into 8 and belongs to the MX25L family. It utilizes the Flash Runner 2.0 protocol and has a memory size of 128 kilobytes. Next is general description of MX25L1005. The MX25L1005 chip allows for sequential reading of the entire chip. After a program or erase command is given, automatic algorithms will execute to program, erase, and verify specific page or sector or block locations. The program command works on a page basis while the erase command works on the entire chip, sector, or block. To make it easier for the user, a status register is included to indicate the chip's current status. By issuing a status read command, the user can check if a program or erase operation has been completed by checking the WIP bit. When the device is not in use and the chip select signal is high, it enters standby mode and consumes less than 10 mA of DC current. The MX25L1005 chip uses MXIC's special memory cell technology, which can reliably store memory contents even after 1 lakh program and erase cycles. Next is data proof of MX25L1005. MX25L1005 is designed to protect against accidental programming caused by unexpected signals during power transitions. When the device powers up, it automatically resets the state machine in the read mode. Additionally, the memory contents can only be altered after specific command sequences are successfully completed. The device also includes various features to prevent unintended write cycles caused by power up and power down transitions or system noise. These features include power on reset and internal timer to avoid sudden power switch due to power supply transition, as well as validation of command length to ensure it is at byte base and completed on byte boundary. The write enable command is necessary to activate the write enable latch bit before any other command can be used to modify data. The bit will be reset under the following circumstances. When the device is powered up, after the completion of the write disable command, after the completion of the write status register command, after the completion of the page program command, after the completion of the sector erase command, after the completion of the block erase command, after the completion of the chip erase command. There are different modes of protection for the flash device. Number 1. Software protection mode. This mode uses the BP0, BP1 bits to specify which part of the flash is protected from the data modification. Number 2. Hardware protection mode. This mode uses the WP pin going low to protect the BP0, BP1 bits and SRWD bit from data modification. Number 3. Deep power down mode. When the device enters this mode, it is protected from all commands that modify data except for the release from deep power down mode command and the read electronic signature command. Next one is the hold feature of MX25L1005. When the hold pin signals goes low, it indicates that any serial communications with the device should be fast. However, this hold feature does not affect the operation of writing to the status register programming or erasing that may already be in progress. To initiate the hold operation, the chip select pin must be kept low and the falling edge of the hold pin signal must coincide with the serial clock signal being low. If the serial clock signal is not low, the hold operation will not begin until it becomes low. The hold condition ends when the rising edge of the hold pin signal occurs while the serial clock signal is low. If the serial clock signal is not low, the hold operation will not end until it becomes low. Refer on screen figure number 1 for a visual representation. During the hold operation, the serial data output is in a high impedance state. The values of the serial data input and serial clock are not relevant. If the chip select pin is driven high during the hold operation, it will reset the internal logic of the device. To resume communication with the chip, the hold pin must be set to high and the chip set pin must be set to low. Next one is device operation of MX25L1005. Number 1. Prior to issuing a command, it is necessary to check the status register to ensure that the device is ready for the intended operation. Number 2. If an incorrect command is entered into this LSI, it will enter standby mode and remain in that mode until the next CS falling edge. In standby mode, the SO pin of this LSI should be in a high Z state. Number 3. If the correct command is entered into this LSI, it will enter active mode and remain in that mode until the next CS rising edge. Number 4. Input data is captured on the rising edge of the serial clock and data is shifted out on the falling edge of serial clock. The difference between SPI mod 0 and mod 3 is illustrated in figure 2. Number 5. For the instructions RDID, RDSR, READ, fast read, RES and REMS, the instruction sequence is followed by a data out sequence. After any bit of data is shifted out, the CS can be set to high. For the instruction WREN, WRDI, WRSR, SE, BE, CE, PP, RDP and DP, the CS must be set to high exactly at the byte boundary, otherwise the instruction will be rejected and not executed. Number 6. During the write status register, program and erase operations, accessing the memory array is disaggregated and does not affect the current operation of write status register, program and arrays. Next one is the write status register of MX25L1005. The write status register instruction is used to change the values of certain bits in the status register. Before using the WRSR instruction, the write enable instruction must be executed to set the write enable latch bit. The WRSR instruction can modify the block protect bits to define a protected area of memory. It can also set or reset the status register write disable bit based on the write protection pin signal. However, the WRSR instruction cannot be used when the hardware protected mode is active. The sequence for using WRSR instruction is as follows. The CS signal goes low, the WRSR instruction code is sent, the status register data is transmitted on the SI line, and then the CS signal goes high. The WRSR instruction does not affect certain bits in the status register. The CS signal must go high at the byte boundary for the instruction to be accepted and executed. The self-timed write status register cycle time begins when the chip select signal goes high. The write in progress bit can still be checked during the write status register cycle. The WIP bit is set to 1 during the TW timing and set to 0 when the write status register cycle is completed and the write enable latch bit is reset. This is the brief study of integrated circuit MX25L1005. Thank you for watching.